strategies for 2 by n games. So, if we have another example, I'm calling example 5 now. We're going to have 2 players, x and y. Player x has 2 strategies to use. Player y has 3 strategies to use. And our payoff matrix is given to us there. If we start off as we normally have done, row minimums, and that's the maximum. Row maximums, and that's the minimum. Those two numbers are not equal to each other. We don't have a saddle point. It's not a stable game. It's not going to be a pure strategy game. It's going to be a mixed strategy game. So we're going to look at this to start with from x's point of view. So x here will play strategy x1 with probability p, strategy x2 with probability 1 minus p. So x needs to think what happens if y plays with strategy y1. Well, x will gain 4 with probability p and 2 with probability 1 minus p. What happens if player y chooses strategy y2? We can get similar expressions there. And for the first time now we've got to think about what happens if player y chooses strategy 3, and we get another expression there. And if I simplify these over here, you could get this done if you wanted to. What we've got to do now is find the maximum. Now if I just show you this graph rather than get you to draw it, what we have here is 3 lines on our graph. Okay, we've got, if you can see in colour, this one here is this red line, this one here is this green line, and this one here is this blue line, and we get this sort of feasible region down here, and we're trying to find the maximum one. The maximum is this point over here. The maximum will always be where just 2 lines cross. Okay, one line will never be in there at all. So what we've actually got here is when the green and the red one meet. So I've identified here is where these 2 meet. And if I rearrange that and solve it, I get a value for p. So that tells me that player x should play x1 4/5 of the time and x2 1/5 of the time. And I get a value of the game as well for that player. So I've looked at that from x's point of view. Okay. I'll just summarise what we had here for that one. We had x1 should be played 4/5 of the time, x2 1/5 of the time, and the value 2x was 3 3/5. So we need to think now, okay, we've looked at what x should do, what should y do? So for y, there were just the 2 lines that intersected over here with these 2 lines. If you look at the graph again, the line that didn't intersect here was this line here, which is the blue line. The blue line came from here. The blue line came from y playing strategy 3. And because this blue line did not feature at this maximal point, that means y should just not play strategy 3 at all. It just does not feature in this best thing here, this best point. So if you can draw the graph and one of the lines does not meet, it's not one of the intersecting ones here, that means y should not play that strategy at all. So y shouldn't use strategy y3 at all. Now it will always be the case that the player with more than 2 strategies will only ever use 2 of them. So let's look at the analysis for y a minute. I can fold my bit of paper up here. Okay, and look at that matrix. We need to know, well, what should y do? Well, if x played x1, y would expect, well, what we need to do now is just check our probabilities. For y here, y is going to play y1 with probability q, y2 with probability 1 minus q, and we've already said they're not going to play y3 at all. So if x plays x1, y can expect a loss of 4 with q probability, a loss of 2 with 1 minus q probability. Add those together and put a minus sign in. that's what y can expect to happen if x plays x1. And if x plays x2, it'll be a loss of 2, with probability q, a loss of 10, that bracket should have been there, with a 1 minus q probability. Add them together, they are losses. If you sort those out, they come out to be minus 2q plus 2, no, minus 2 I think, and minus 10 plus 8p. Sorry, q, thank you. Okay. You get to solve that, q comes out to be 4/5. So once we have that, for q, for player y, we have y should play y1 4/5 of the time, y2 the rest of the time, because we'd already said y3 is a strategy that should never be used. It did not feature in that maximum point on our intersecting lines. And again, if you work out the value of the game for this one by substituting those values into here, you do get the value of that game is negative of the value of the game we had for the other player. And I have made a note down here in your OCR books on page 86. There was quite a good summary, I thought, of the 2/n game. This is page 86 of your OCR books. That is the process you go through to solve a 2/n game. I thought actually that summarised it quite well.